All right, this is our next example, and this one we're kind of working backwards. We are trying to find mu and which is our mean and our standard deviation. So they give us our probabilities, they give us our x values, and we are working with that same z-score formula to solve for our mean and our standard deviation. So let's kind of get started with a little picture here just so you guys can wrap your heads around what's happening, and then we can go from there. Once again, I like drawing a picture because it allows us to ask the question when we're done at the end of the problem, does it make sense? Okay, so since I'm given two different probabilities here, I'm going to draw two different pictures so it doesn't get too complicated. Look at that, that was a rare sight. I did it in one swoop. All right, so in both of these, I don't know my mean, so I'm going to leave it like that. So if I get that set up, and my variable is x. Now, here's where we got to think a little bit. Okay, so let's take this first one, 10. Okay, where do we place the 10? Is 10 going to go to the right, or is it going to go to the left of the mean? Well, that's all based off of this percent right here. And it's also based off of the fact if it's greater than or is it less than. So this is saying that for the probability that x is less than 10, so to the left of 10, is 75%. So since 75% is more than 50%, then we know that 10 is going to lie to the right side of the mean, okay? Because this shaded area to the left of 10 is 75%, or 0.75. So that is 0.75. Make sense? And so we will calculate our z-score here in a second that correlates to 10. But let's kind of come over here and do the same thing for 12. And let's see, where would you place 12? Would you place 12 to the, obviously, once you've placed 10, it's easy to place 12 because 12 is to the right of 10. So let's put 12 like even farther down here, okay? Now, this probability is x is greater than or equal to 12. So that means that we're talking about to the right. So they're giving us this itty bitty baby corner that is to the right. So this little region is 0.1, which I want you to automatically think about what's the complement of that, okay? Because if you've seen all of these examples so far, when we find a probability from the z-score table, our probabilities are probabilities that are greater than 50%, okay? We're okay here because we're to the right of the mean, which is good because that's where we get our probabilities from in that z-score table. But they don't give us probabilities like this. You're never going to find a probability in that table less than 0.5. So what we have to do is we have to use this part. We're not changing the question, we're just coming at it from the other side, much like we do in a lot of the questions in chapter 7. So this probability, the complement to 0.1 is 0.9, okay? So this is, I'll add my z-scores down here. Let's calculate our z-scores for both of these, okay? Well, if we start to use our formulas, okay, and we think about this, we kind of already know our z-scores, okay? Because if I try to jump into, let me explain this for a second. If I try to go right to this formula, and I'm like, okay, cool, I've got my probability. Where do I put that? I don't know. You're gonna have a lot of unknowns here. This is what you're gonna have, and you're not gonna get very far having 3 variables and 1 problem. So we don't do that, okay? So we gotta come back to the drawing board and think about a different way to approach this. And what I want you guys to do is I want you to come over here to your distribution table, and I want you to look, I gotta clear this off for a second. I want you to look way at the bottom if you scroll all the way to the bottom here. and find your critical values, okay? And you're going to notice that everything from this problem, this 0.75, is right here, and our 0.90 right here. We already know our z-scores. They're given to us. And there's only a certain number of probabilities right here that are provided to us. There's 9 of them that we have these critical values, okay? And so the more you guys practice this, the more you're going to start to recognize those numbers, and you will kind of go to that piece first. So always check those critical values before you dive in to finding a z-value when you're given a probability. So this, for 0.75, I know the z-score from the table for 0.75 is, what is it, 0.674. And the z-score for 0.9 was 1.282. Perfect. All right, so that's when they give you a probability. You're not trying to find the probability, they give it to you. You're just kind of working inversely to get your z-scores, okay? So that table can be used going forward or going backwards. So just kind of playing with what you're given. All right, so we've got that. Now we can go to that formula and we can try to calculate it. Now, always, always, always in algebra, when you guys are given 2 different variables to solve for, we have to find mu and sigma. We're probably going to need 2 equations, okay? So if I use my z-score formula, okay, I'm going to plug that in here. I've got 0.674 is equal to, my x value is 10 minus the mean divided by the standard deviation, okay? And this one is going to look almost identical, except for over here on the z-score, we have 1.282, and our x value is 12, okay? So I've got 2 equations, and yes, I could start to put these together right now, but I would rather do a little bit of work with them. So when I do a system of equations, I can use elimination to just add or subtract them. So what I'm going to do is, in both cases, I'm going to multiply both sides by the standard deviation. So these cancel out. And so this side would be 0.674 sigma, and just be careful when you draw that because it definitely looks like a 6, is equal to mu, or 10 minus mu, sorry. And what I do is I add this over here. So it looks much like a just standard system of equations where you have both your variables on one side, it's addition, and you have just a value. So I'm going to put a little squiggly under here because I got that to where I want it. I'm going to do the exact same thing on this side. So once you've seen it done once, you can kind of speed that process up. So you multiply both sides by sigma, so it's gone on the right side, and then add mu, so you've got 1.282 sigma plus mu is equal to 12, and you've got that where you want it. So if you take these 2 equations now and you put them together, it doesn't really matter which one you put on top or the bottom. I did this, I did 1.282, put this one on top, and this one on the bottom. And as you can tell, if I were to add these, nothing really cancels out. So what you have to do is you have to subtract these 2 equations. So I'm going to subtract all of these. And if you want, you can put like a little minus sign in between everything if you want to. And these cancel. And if you subtract these decimals, you get 0.608. Sigma is equal to 2. And if you divide by 0.608, you get sigma is equal to 3.29. And that is 3 significant figures. That's perfect. And then I can plug this back into any equation that I want. It doesn't matter which one. So I'll just plug it back into, I guess, this top one. So if I do 1.282 times 3.29 plus mu is equal to 12. And if you multiply and subtract that value from 12, you are going to end up with a mean value of 7.78, correct to 3 significant figures. And that, guys, is a system of equations mixed in with normal distribution. So you know how ACE likes to blend all these different topics, algebra, and they blend them in very well. And that is it. So it's kind of like a little puzzle. Just work a little bit with what you've got, and it'll lead you to a new piece, and then you kind of just keep going until you solve it. So